Hi Ankush, good evening.
Good evening, sir.
Yes, welcome.
So, is this a class tomorrow also, sir?
Pardon, tomorrow also we are having class. Yes, yes. Tomorrow is the last day.
Okay.
So, so tomorrow I have planned that we'll have uh,
Monday, sir, it's offline, right?
Monday it's offline. Yeah.
What will be
So
time?
timing will 9:30 will all. In fact, I have arranged all the breakfast and everything. So come there only directly to institute. So then 9:30 will start inauguration and maybe by 10 o'clock we'll start the session.
Okay, 10
So
to
so
how much time, sir? 10 to?
4:30, 9:30 to 4:30. That is the schedule.
Okay,
So,
okay.
only thing the challenge which I see which we face because many faculties how many of them are relieved from their colleges. So that is the big
Okay,
challenge.
that is what for the same I am actually asking.
No, but try to get relieved because this is the ICT's direction that they should
Mhm.
be relieved. But I don't know. So that's a challenge. We need to take it.
Yes, sir. Yes, sir.
Always, yeah.
Yes, yes, sir. Right, sir.
Yes, sir. Yeah,
Okay, sir.
yeah, yeah. Sunal, you are ready?
Yes, sir.
Okay, so we'll start sharp 7. You can start here.
Okay, sir. ना पड़ेगा और दूसरे स्पीकर ना पड़ेगा और दूसरे स्पीकर
Sonal, you can.
Should I start, sir? ना पड़ेगा और
Please.
दूसरे स्पीकर
Okay.
Am I audible and visible?
Yes.
Good evening,
Am I
everyone.
audible
This
and
is Sonal
visible?
Sudbe, your host for the
Yes.
day. So, as we all know, artificial
Good evening,
intelligence
everyone.
technology
This is
has
Sonal Sudbe, your
revolutionized
host for the
academia
day.
in terms
So,
of
as we
organizing
all know,
classes.
artificial
So,
intelligence
today's world has witnessed tremendous innovation in the field of artificial science, machine learning, and deep learning. So, from the past few days, we have witnessed amazing sessions by our guests. So, today I would like to welcome you all to the day 5 of our program. Shukla sir, over to you.
Thank you so much, Sonal. And the all 5 days, like it has gone like anything. I would like to just brief all that. Okay, what we had since day one, what we have learned so far, and that will give you an insight that okay, what we have learned and what is left in all 4 days. So if you remember that the day one, we have started with the introduction to data science and machine learning. So we had the introductory session, and then that was followed by the linear regression using a Boston housing case we have taken. So in that we have tried to find it out how the in Boston city how the property prices are getting impacted with the different kind of uh, parameters. Then we have seen the heat map on that day. Also, we did model diagnostics. Then R squared also we learned that day, and then adjusted R squared we learned. Then mean absolute error, that is also we learned that day. Also MAPE we learned, that is a MAPE. So that was the day one. And in day two, we have learned the something advanced we had gone, and we have learned about the logistic regression model. So in the logistic regression model, we have done many cases, and also we have learned the dummy variable creations and how it is being used. Then we have done the model diagnostic of recall, then F1 score, then precision technique we did. Also ROC curve we have seen there, and also the yes curve, that is we have seen. So we did, even day two was very interesting, and that was a like day one was a part of the supervised learning, and then in day two it was a more of unsupervised learning techniques. Then day three is started again with the unsupervised learning techniques, and in that we have gone through that the a priori algorithm versus ECLAT algorithm. Then also we have learned the sparsity, density, also the parallel coordination plot we have seen. So that was we did in day three. Now in day four we have more learned about, and that was the yesterday. I'll just brief about the what we did. So we did about in day four we did the market basket analysis, also the association rules, then Jacquard index. Okay, that is the similarity index which we studied. Also we have studied the k means cluster. Okay, so that is the we did the cluster analysis yesterday, and also the service uses pattern, that also that was the last which we did, and that was how we can the relate the different products and also the services being used, and that can be related. So that is what we have gone through so far, and now we'll be moving ahead. So let's have a uh, some reflections from you also. So I invite anyone like who'd like to come, and so anyone can come forward and yes, you can share your experiences. Yes, Rabin
It's,
sir.
yes, sir. It's good to have training like this where amazing part is the tutor, Mr. Mohan sir, is so expertised in all the way utility tools like Python, R, SPSS, and whatnot. It
Okay, yeah,
shows
yeah.
it shows how immense he involved in such kind of all programming skills and analytical side. So, learning one part, whereas getting inspiration from persons like professionals like him, it's a great to see. And thanks to organizers like this program and AICT for giving you funds, especially.
Yes, sir.
Uh, that exposed a little bit towards the expertise by people in the field, I feel.
Very true, sir, Dr. Rabin sir. So in fact, we are grateful to AICT for such initiative in that we are, although it seems forcefully we are being put there, but then the usefulness of this is very high. Yeah. So even I was interacting with my faculty members, so they are also after learning after so many days when they couldn't have time to go through all this. Now they're excited and they want to do a lot of research. So that is the beauty of this initiative by AICT. So anyone else, please, I invite you if you can share. Anyone else? Ankush sir, you would like to say something? Himbade sir, still people are joining. So I think shortly we are going to complete the quorum. Anyone can come forward and can say something about the workshop which attended. Anyone can come forward. Mane sir has also joined.
Hello, sir. Nitin here.
Hi, yeah, sir. Welcome. All are waiting for you. So
Yeah, I was
just
here 5 minutes back itself. When you
okay.
said
Yes,
people
sir.
are joining, I was just here.
Okay, sir. Welcome. So, will once again a warm welcome to Mithun sir, and that is whatever we were taking the reflections from all the participants, and it has been a very you can see all are enjoying the sessions and the knowledge which they're getting it. That is really, it's going to be very useful. That was we were discussing. So once again, we welcome you, sir. And now, on behalf of all my participants, on behalf of AICT, uh, it's a like very warm welcome, and our uh, it's a, like wonderful sessions which we are having. So the gratitude we want to convey to you. That is what at the beginning itself, because the 4 days we had you. So thanks a lot, and sir, kindly take it now and for the further sharing your knowledge. Thanks a lot, sir.
Sure, sir. Thank you so much, sir.
Bye.
Thank you. Thank you.
Bye.
Okay, I just want to hear from the participants about a quick recap. Otherwise, it will become like a monologue wherein I am talking. Right? It is better that we have an interactive session. If you
Yeah,
could just give a high-level summary of what you have done, what you have learned, rather. Don't worry whether it's right or wrong. In the meanwhile, it will also help me sort of set up the system and such things.
correct. Mani sir, you are there? Pramod sir? Or anyone can share who is anyone can come forward. Ankit sir? Pallavi ma'am, would you like to say something? Share something? Your reflections?
Hello, sir.
Yes, ma'am. Yeah, ma'am. Come. Yeah, please.
Right from beginning, right from scratch, many of the fundamentals are being taught to us, and in a very elaborate way, they are taking all those aspects. I'm really enjoying it, sir. Thank you so much.
Yeah, thanks a lot. Thanks a lot, ma'am. Yeah. Anyone else? Yes, Ravin sir. You want?
Yes, sir. Started with learning on logistic learning, logistic regression models, and covered with like cleared many of the aspects where how it differs from regression side. Generally, we use more regression in our studies, and where here we got a little bit more clarity on logistic where we need to apply it. And the next following there was on decision tree. That also it cleared for me, especially in the personal level. I got to clear so many aspects clear wherever I have doubts. Those things will clear to me. Then yesterday was one more interesting session. It started with a priori technique where market basket analysis.
Yes, yes.
Actually, we are from pharma side. Generally, we think more towards drugs and their properties, but this was one more aspect. Even it gave another dimension where the analyticals you can take up to that level also. Right? So
Correct, correct.
yeah, this was an attractive session yesterday. What I feel, this one. So enjoying.
Very true, Ravin sir. Now you can even affiliate the medicines like which are affiliated to each other, and then you can take out a model for yes for the pharmacist
Yes, sir. Yes, sir.
and the industries area. So we can think of even those lines also. Very true.
Okay.
Sir.
Yeah, yesterday, in connection with yesterday's talk only, there was the data it was used like retail shop, how the mindset of buyers in which combination they buy. But in the
Correct,
case
correct.
of pharma retail side, getting such information it is a little cumbersome task. So I wanted to know from you, your side, and how we can generate that Excel sheet or CSV file wherein there is information of the buyer, which kind of medicine he buys or she buys, and then we can put for such analysis. Actually, pharma retail, it is not that well organized in terms of documentation.
Very true, sir. Very true. But I have seen nowadays, like if you go to take medicines, so they note down the doctor's name and also they note down the medicines which you are taking and your name also. So many of them are having the computerized system,
Yes,
and
sir.
they don't give. So the those who are a bit organized, so they do in this way.
Correct, sir. That is correct. Wherever, like the prescriptions are there with, like the patient or a person who are little bit more standard way. In such case, they are giving you bills as well as this. But probably you might have noticed or not, some unethical practices also that goes.
Correct, correct, correct,
So
correct.
such kinds we can't able to catch hold on it or control over it. So that's what I was little bit like analyzing myself. How can we take it to pharma retail and how can we generate this data? That is little bit difficult there.
Yes. We'll take input from Mithun, sir. Some how the pharma sector can be use the market basket analysis.
Good evening, sir.
Yes, ma'am. Yeah, Anuradha, ma'am.
Yes, sir.
Good
So,
evening.
yes, good evening, sir. Yesterday's session was very much interesting. Sir has explained us about this market basket analysis and which products we can pair up together, which products can be positioned together. And for that, sir has explained in detail that support value, confidence value, and the lift value. And that ultimately sir has elaborated if the lift value is negative, then that product cannot be positioned together. So basically, and by using that IBM SPSS modeler, sir has demonstrated the entire retail shop product association. So it was very interesting session. Thank you, sir.
Yeah, yeah. Thanks, Anuradha, ma'am. Thanks a lot, yeah, for sharing this. So good. So Anuradha, ma'am, you are learning a lot, and even the you are going deeper into that, and by remembering all technically, yeah, that's really good. Yeah.
Yes, sir. Yes, sir. So, in detail, sir, sir is explaining that everything, all that technical terms, so that we are learning for the first time. So that is the key inputs of this session.
Correct, correct, ma'am. Yes,
Uh,
yes. Thanks a lot, ma'am. Thanks.
thank
So anyone else? Anyone else would like to share something? Pramod sir, you are there? Mane sir?
Okay, shall we get started with today's portions?
Please, sir. Please,
Okay.
please. Yes, yes, yes.
I'll just give you a high-level perspective just to sort of jog your memory about what we did. First day was about linear models because that is the foundation of all your ML and AI models and such things. So as the name itself suggests, linear models are used when there's a linear relationship. So two cases we discussed. One is simple linear regression. Second one is what's called as multiple linear regression models. Simple linear models, basically you have one independent variable. Multiple linear, you have multiple variables. That's the first part. That's the first day. We looked at certain model diagnostics, before model diagnostics, the heat map, that is very important. Then we looked at how to split the data set into training and testing. 70% we took in training, 30% into testing. Then we look at certain model diagnostic like R square. We looked at mean square error and mean absolute error. These are three things that we looked at, day one. Day two was about logistic regression. Fundamentally, the difference between linear and logistic is that logistic regression can be used to model a categorical dependent variable. Particularly, we looked at a case of binary logistic regression model, which is telecom using the telecom example. How to treat missing values, what missing values can do, PD dot is null of any of, that is the function that we looked at. After this, we looked at how the output of logistic regression is very, very different from that of linear regression. In the case of logistic regression, since you're predicting a class variable, you'll get predicted class. The output also, you'll be looking at confusion metrics, accuracy, precision, recall, F1 score. These are some of the things that we paid attention to. Third day, we moved to decision tree, which is a non-linear approach. Some of the advantages are that it's a non-parametric approach. It can handle missing values. It can handle mixed data type. It supports both continuous dependent variable as well as categorical dependent variable. One big problem of decision tree is that it leads to overfitting. That is the third approach. And yesterday we looked at a priori algorithm, which is a unsupervised learning technique. Now, when we look at these, each of these unsupervised learning techniques, not just a priori, in the closing stages, we looked at what is called as k-means cluster analysis. Again, an unsupervised learning technique. We looked at telecom and service usage pattern. We were able to understand using the k-means cluster analysis. 2 points there. In k-means cluster analysis, basically the sample size usually should be greater than 1,000, and the variable should be scale. And based on the profile, we can just identify who belongs to which cluster, so on and so forth. In the case of a priori, we looked at support, we looked at lift. Support is one thing, lift is another. We also looked at support, lift, and anything else that we looked at? Confidence, right? These are three metrics that you need to look at. We, of course, talked about antecedent and consequent. Now, what I want to talk about today is another interesting technique, which is called as neural network. I want to talk about a technique which is called as neural network. Okay, it must be in downloads. Are you able to see my screen?
Yes, sir.
Okay, any idea what is neural network? Why do we need neural network? What happens in the case of a neural network? Any idea at all? Okay, let me just give a perspective about what is neural network and such things at a very high level. So fundamentally, when we are talking about neural network is used to model non-linear data. I repeat, neural network is fundamentally used to model non-linear relationship. So neural network is widely considered as a black box approach. Black box means it does not give you the rich input, rich output that you got in the case of linear regression. So much of the theory that we are talking about in today's day and age was actually written not today, much of the output, much of the technique, the theory behind neural network was written way back in 1940s and such things about neural network. Now, how does a typical neural network look like? And just see here, this is the this is the diagrammatic interpretation of neural network. So you have a set of nodes here, which are called as input layer, right? These set of nodes are called as input layer. Then in the center, what you have is basically hidden layer. You have hidden layer. And then at the end, what you have is basically an output layer, right? You have input layer, hidden layer, and output layer. In the input layer, what we do is basically we push a couple of variables in. You can push any number of independent variables. And once you push these input variables in, the neural network basically does some computation. It does some processing and evaluates what are called as weights. It evaluates what are called as weights. And based on these weights, basically, based on the assigned weights, it decides which variable is important in estimating the output, and you get the output out in the output node. This is the output that comes out. You can fetch the output from this output node. So this is at a very high level. This is what is called as input layer, hidden layer, and output layer. Since you have 3 layers, it is called as MLP, multi-layer perceptron. This is what is called as a multi-layer perceptron. So the same thing, if I have to explain through another diagram, I'll just go to another picture here. You can see if I just zoom in the earlier output, it looks like this. Any stage in a neural network, I have x1, x2, x3, all the way up to xn. They're pushed in, and you're estimating the weights of each of the input variables. And once you estimate the weights of each of these input variables, you take the sum product, multiply the weights by x1 plus weight into x2 plus weight 3 into x3, so on and so forth. And then you push it into a function which is called as the transfer function. This transfer function is also sometimes called as the activation function. Now this activation function takes the result out, right? It just pushes the result out. Now in the output window, in the output layer, in the output node, you can get the output. Now one question that I want to ask my audience is basically, do you know what do you mean by weights? What are these weights that you're talking about? Are you able to hear me, please? What are these weights? Where are they coming from? How do you estimate the weights? Who is calculating the weights? Why is it so important for us to understand about neural network and the weights, the way the weights are estimated?
So probably sometime you use this word. I feel it may come from y is equal to mx plus c only, sir. Somewhere in last 2-3 classes we heard about it.
Okay, okay. Any other answers?
Sir, please keep the figure on the screen, sir.
Okay, sure. Yes. Now, instead of these weights, instead of this understanding it like this through this diagram, I'll just explain the same thing through. Let's just get all of these hieroglyphs out, and let us just make it very simple. And I'm just going to explain the concept of neural network through a simple diagram. Okay. Are you able to see this? Basically, I opened up Microsoft Paint. Are you able to see empty?
Yes.
Yes, I just opened up MS Paint, and through a simple story, let me just explain how neural network works. Okay, let's just forget all this complicated terminologies and such things and start with a fresh, with a clean slate. Now, to begin with, let us say there is a child, and this child is basically getting bored, right? So she asks her dad, basically, what do I do to relieve my boredom, right? So the parent basically gives her a task. What are the tasks? Basically, he gives 3 empty buckets, correct? He gives basically 3 empty buckets. So let me just draw these 3 empty buckets first. Okay, the first bucket, okay, the second bucket he gives, And finally, this is the third bucket. He gives three different buckets. Right? These are the three buckets that we have. Right. Next thing, basically, what he does is after giving these three empty buckets, he gives two additional buckets, which I'm going to show like this. This is the next bucket, and this is the next bucket, right? So there are five empty buckets, and to finish this discussion, he'll give one more bucket here. He'll keep one more bucket here. Correct. Now this bucket, the final bucket, basically, let me just use a different color for this. Let me just go to view, help. Let me push this as black. Okay. Okay, so this is in my paint. So you have 3, 4, 5, 6 different buckets. So to the first bucket, the father basically gives what? He puts red color. He fills it with red color paint. Second one, basically he puts blue color paint, and the third one he puts green color paint. So there are 3 empty buckets initially, and the father basically decides to fill it with red, blue, and green. The next 2 buckets he leaves it as empty, and the third one he basically says to the child, I'm giving you three different colors, 3 different buckets of paint. This is a bucket and paint example. 3 different colors of paint. You are allowed to do anything. You can mix it up in whatever combination you want, right? You can mix up red, blue, green, however you want, but the end result should be black. And if this is black, basically, it means that at the end of the day, if you're able to get a black color, you're able to generate a black color, you will get to see a movie, or I'll take you to for ice cream, whatever, right? So once this happens, the child basically, kids are very, very enthusiastic. So what the child does is basically, the child now tries to make a connection between red, blue, and green. So what this child does is, okay, let me just use this. I need an arrow. Okay, I think this is a better arrow. Slightly big. Just, I think this is better. Yeah. What the child does is basically, it just takes this, right? And it takes a portion of the red color and puts it in the second bucket. Similarly, it does the same thing, wherein it just takes another portion of the blue color and it puts it in the first bucket, right? I'll take a easier arrow. I think insert. Control C and Control V. Why is it coming like this? It should come like this. Okay, just to show the direction of the arrow. Okay, so then basically you can do one more Control V and try to establish a connection between these two. I hope you can see this, and then one more Control V, wherein you can just try to establish a connection between the green one and the first bucket. Okay, so what the child is basically doing is she's just trying to mix up. She's just going to take up some color, and she's just going to put it in the second bucket. Similarly, she takes another portion of red, blue, green and mixes it up in the second sort of cylinder. And once you have this middle layer, in the middle layer is where the mixing up happens. Now she has got a very complex color, which she further uses to sort of mix up in the final color. I hope this is clear to everybody.
Yes.
right? I'm just trying to draw arrow. The arrow is not coming out well here. So I think very bad way of drawing an arrow, right? Something like this. I think it'd be better. Control C. And, right. I think this would show the direction of relationship. Correct. Right. So this is one more arrow here. Okay. These three buckets. These three. She's taking the paint. She's doing the same thing with the rest of the items as well. Wherein, let me just finish off this, and then again finish off this. Right. So red, blue, green, mix it up. Red, blue, green, mix it up in a different combination. Take that mixture, and then basically fill the last bucket. And then she asked, basically, is this black color? Right. In the first iteration, basically, it is black. It may not be black color. So the father says it is not black color. So what the child does is basically she just flushes out the middle layer and the last layer. She goes back to the red, blue, green, and takes a different proportion of red, blue, green. Again, mixes it up. Now this time it's in a different proportion. Let us say the first iteration she might have taken this in the ratio of 1:2:3. It didn't work out. So in the second iteration, what she's doing is basically she's taking a different combination, 3:2:1. Right? She mixes it up, again mixes it up, again she takes the combination and tries to fill it up in the third one, and she asks, basically, is this red color? Again, the father takes a peek at it and says it is not red color. So let me just show this relationship in an Excel sheet. Right? You can just see here in Excel sheet, you have red, you have blue, and then basically what you have is basically green. Correct? And this is the first iteration. Correct? I'm just saying that this is the first iteration. In the first iteration, she may have taken it as 1:3, 2:3. It didn't work out. So in the second iteration, she basically says, let me just take a higher proportion of red and a little more blue and then a little more green. Then finally, she comes to the third iteration. So the result here is that it is a failure. You are not getting a black color. We are continuously looking at a black color. So she has failed here. She has failed here. And next time she just tries to downgrade the importance of red. She tries to upgrade the importance of blue. And finally, she gives a green color here. Now, this is also, let's say she has failed, right? The father keeps rejecting it, saying that this is not black color. Let us say if you keep repeating this experiment 20, 30, or let's say 50, 60 times, correct? In the 60th iteration, she may have found out her combination 4-5-1. And when she sort of mixes up in this combination, correct? When she sort of mixes the red, blue, green in 4:5:1 proportion, basically, she reaches the ideal combination. She is able to generate the black color. Now, in this entire experiment that we see here, right, you may have different combinations here, right? I'm not doubting this. You may have different combinations here. You may have different combinations, right? Let me just go ahead and fill copy cells, whatever, right? And then basically she does not reach any, she does not get any common, she does not get the desired result at all. She keeps failing again and again and again and again. And at some point, nobody can give a guarantee as to when she'll succeed. But she has, in this case, succeeded in the 68th iteration. She's been able to generate the final color, which is black color. So in this experiment, if you actually look at it, let me just go back to this paint. When you look at this entire experiment and compare it with the original diagram that we have, this red, blue, and green are nothing but the input layers, right? You can just treat them as though it is the input layer. And these empty buckets, you can call them as the hidden layer. And the final output, the black color output that we're looking for, that is nothing but your target. So in a typical neural network, if you compare these diagrams with, let's say, if I replace these cylinders with circles, you will be able to appreciate the discussion that we were having so far. That is, it will look something like this itself. See here, you have input layer, you have hidden layer, and then you have the final output layer. In the input layer, what we are doing is basically we are adjusting, we are just taking a proportion. So what are weights? Weights are nothing but proportions. It depends upon how much of for the input are you taking in. Not a, so in the red, blue, green example, red, if you mix it up, if you take 40%, and blue if you're taking 30%, and green if you're taking another 30%, it means you're given the highest weightage to red. You're taking 40% of red, and you're taking little importance to blue, and further little importance to, let's say, green. So this giving importance is nothing but your weights in a typical neural network. So are you clear with this? What is the concept of weights? Weights are nothing but constructs which decide how much of the input are you taking in. Because in a real-time scenario, you may have 20 variables. You can't give, here in the example, in the bucket and paint example, I just confined myself to red, blue, green. In a real-time scenario, if you have to replicate it, you may have 25 or 30 variables. You can't give equal weightage to all of them because all of them may not equally contribute to the output variable. So which variable you give how much importance to, that is nothing but your weight. Are you able to understand?
Yes, sir.
So this idea of changing the weights, basically, this idea of changing the weights is not a new concept, right? So then there's not much of mathematics involved in this idea of changing the weights and such things. It is mostly an experimental process. So if you look at this Excel here, in the 67th iteration, basically, we got a solution. Now, many times you may get you may get the solution after 600 or 700 iterations. Nobody can give a magic or a silver bullet saying that after 60 iterations your solution will converge after 70 iterations. No, you have to keep on doing this. You have to keep on experimenting. You have to keep on changing the weights, produce the output, compare that output to the target. If it is very far, it means that you have failed. If it is very close to each other, it means that you have succeeded. Now, as you can see here, this is the experimental process. Now, can you tell me if there are any two problems with this approach? In the approach that we did, can you identify any two problems?
Sir, hope so. In my view, once you start the first iteration, whether from first iteration to second iteration, when you are going for whether you are in right direction or not, probably I feel one difficulty is there.
Okay. Okay. See, one of the main process, one of the problems here is this is a computationally intensive task. This is an iterative procedure. Iterative procedure means 30 iterations you may get the solution, or like 60 or 700 or 800 iterations you may get the solution. Nobody knows what is a magic bullet. You have to keep on trying because it's an experimental process. And because it's an experimental process, your computers and such things should be very, it is a very computationally intensive task. Unless your desktops and such things became very powerful, we could not operationalize this theory. Though the theory was already always there, the Hep's corpuscular model and Pete McCulloch's earliest theory about a neural network was proposed in 1930s and 40s. But till such time as your desktops became very powerful, we could not do such a complex task. Now compare this with linear regression. Linear regression, you had a mathematical formulation y equals mx plus c, wherein you could precisely come up with what is your beta coefficients and such things. Now, when I show you this diagram here, what is the mathematics behind this? There is not much of mathematics. What is the equation of behind the neural network? It's very difficult to describe the equation of neural network and such things. Now, that's why this traditional statisticians are very skeptical about this approach, because at the end of the day, you get nothing with this. You'll be able to solve very complex problems, but there is not a single straight line equation that you can pull out and say, this is how a neural network model behaves. Correct? We have gone beyond equations and such things at this stage. So neural network in that sense is a neural network is I use to model non-linear equations when there is less clarity, when there is more noise in the data, when there is non-linearity in the data and such things. It is best that you use your address within neural network. Let's say you run a linear regression model, you get a low R square. Then it means that there's a non-linear pattern which is not addressed, and therefore it is best to come to neural network. This is about neural network. One is this. Second problem that you can see here is when I was just speaking about the weights and such things. Correct. When I was just speaking about the weights, when you look at the weights are basically, it can take any value. It can be 2.5 from minus infinity to plus infinity. It can take any value. Correct. How do you determine the exact value? It is not so easy for anybody to determine the value. So once you determine the weights here, correct. Let me just show you this diagram. Right. You push the inputs, you get the weights. You take the sum, you get the weights. And once you get the weights, you multiply it by the original variable. What you need to do is basically you just need to add up W1, right? Find out the weight for the first variable, multiply it by the first variable. Estimate the weight for the second one, multiply it by the second variable, plus weight 3 into x3, right? Just do a plus, and then basically you can just go on like this, right? How many ever variables that you have. Now, there are two problems here, right? If the input variables are in different units, say, for example, one variable is actually measured in, let me just zoom this in, right? You found out the weights. The story of the weights is over. Now, let's say if one of the variable is in distance, is about distance from, let's say, Delhi to Bangalore, which is measured in kilometers. Second one is basically the time taken, the time taken for me to do any activity. It may be in minutes. If you look at distance and such things, they are large numbers, 40,000 and such things. If you look at time taken, they are smaller numbers. So is 1 kilometer greater or is 1 minute greater? If I ask this question, it's a bit meaningless question because you can't compare apples with oranges. Therefore, when you have the variables, input variables are in different units, you need to bring them on a same scale. And therefore, to bring them on the same scale, you pass it into a function which is called as a transfer function. But that is not the exact or the correct description of your transfer function. Let me just show you this. Diagram once again. See, we are estimating the weights and passing it through a function which is called as a transfer function. What is this transfer function or activation function? Remember, at the end of the day, your neural network works just like your brain. There are millions and millions of neurons that are present in the brain. And your neural network, the artificial neural network which you are talking about, is developed based on our brain itself. Now, if you take a chalk piece and prick yourself and push it into your hand, nothing happens. You don't feel the pain. Correct? So you'll still smile. If you take a pin and prick it into your skin, it'll really hurt. Why? What has happened? When you take a needle and prick it, your neurons get basically activated. Once it gets activated, it fires a signal. The same way, this neural network is also modeled. When you take W1 into X1 plus W2 into X2 plus W3 into X3, you may get a large number. That number becomes very difficult to interpret. Therefore, we take it through a function which is called as a transfer function. And if that function exceeds a particular threshold, the neuron fires. Otherwise, it does not fire. So typically, there are different kinds of transfer functions. Let me just show you some of the transfer functions here. Ignore all these things because this is not within the syllabus. But though I'm just showing you, right? Can you see this one of the transfer functions? Are you familiar with this? Are you familiar with this?
Yes, we are familiar.
What is this?
This is a S curve.
Yeah, this looks like S, but it typically S curve can also be used, but that starts with 0. S curve, if you see, it is limited between 0 and 1. I'll show you the S curve also. Yeah, S curve looks something like this. The sigmoid function which you use for logistic regression, it lies between 0 and 1.
Okay.
Correct? This is your S curve above 0. Right. Now, this is one of this sigmoid function can also be used as a activation function, but people usually prefer to use what is called as the tanh function. Now, the tanh function, if you look at the vertical axis, the maximum is +1 and the minimum is -1. So if it is close to -1, the neuron does not fire, right? If it is close to 0, the neuron, let's say, half fires. And if it is close to 1, the neuron fully fires. So if the neuron fires, basically, it means that the input signal is strong enough for it to send an output. So this is how neural network basically works. Is it clear? So let me just go back, take you back to the original. Ignore all these things and you can just focus on this. Right? Input layer, determine the weights. Let me just show you this. Input layer, determine the weights, multiplied by each of the original variable. You'll get a large number. That large number, you cannot interpret it. Therefore, you pass it through a function. That function may be tan hyperbolic, sigmoid function, or any of the other function. You'll get an output. And that output can be taken out, which basically tells you whether a person has defaulted or not defaulted, right? But this is a non-linear setup. So this is the main idea behind your neural network model. Please tell me if you're able to follow this.
Yes.
Okay. Now here in this bucket and paint example, if you see, I just give the example of a child who is just manually changing the weight. You don't have any child or nobody is adjusting the weights and such things. What you have is basically you need some kind of a mechanism which can help the algorithm learn. Right? What is that mechanism? I'm just going to tell you. Please tell me if you are able to understand this, see this Word document. Are you able to understand, see this? Are you able to see this document, please?
Yes, we are able to see.
Now I'm going to define a measure which is called as dy by dx. So any idea what is this dy by dx? What does this give me, dy by dx? Very simple measure.
It is a derivative, no, sir?
Yes, exactly. It is nothing but your derivative. It is nothing but your derivative, right? dy by dx. It's nothing but your rate coefficient, which means that rate of change of y with respect to rate of change of x. So when you change your x, to what extent does y change? Right? When you change x, how does your y behave? Now, right? This is a typical rate measure. So can I call this a slope? Can I call this a slope? Or better still, I'll just call this as gradient. I'll just call this as gradient, right? Your dy by dx is nothing but your gradient, which means basically rate of change of y with respect to rate of change of x. When your x changes, how is y behaving? Now, in this case, what I'm going to behave.
You are not audible, Mithun.
Hello, guys. Sorry, there is a
Yeah.
power was off. Sorry,
Okay, okay. We could understand. Yeah, something. Yeah.
the power goes and comes. It had happened twice.
Okay, okay,
Uh,
okay.
so yeah. So I was just explaining about this. Dy by dx is called as the gradient here. I hope you can see my screen. Can you see my screen, please?
Yes, we are able to see.
So here, just as we have dy by dx, we can just define a measure dE by dw, which means basically dw. Why dw means basically you change the weights and look at what is the level of error that you're producing. If upon changing the weights, the error in the prediction increase, it means that that is not the correct way to change the weights. On the other hand, if by changing the weights, if your errors go down, it means that the accuracy of the prediction has increased, and therefore that is the way, that is the best way to change your weights. So this is like, if I can give you an example, dE by dW, how does this work basically? It's just like, in the morning, sometimes when you wake up, your vehicle does not start. So what you do is that you go to a nearby garage so that you can get it repaired. That mechanic does not understand much. So what he does is basically he tweaks and he tries to hear the noise. If it is very noisy and you're not able to hear the noise properly, it means that the way you're changing the way he's changing is not correct. So he tries to move in the other direction. He tries to change the idling in another way so that the noise is basically less harsh. You keep on tweaking this. The same way here, I am playing the role of a mechanic here, wherein I'm just changing the weights. Upon changing the weights, I look at the error produced. If the error produced increases, it means that the way I'm changing the error is the way I'm changing the weights is wrong. On the other hand, if upon changing the weights, my error goes down, it means that the way I'm changing the weights is correct. Now, why I'm explaining this is because many times uh, this is what is called as gradient descent algorithm. Algorithm. dE by dW is gradient. Descent means it should go down. Your gradient, your slope should fall. If your slope falls, it means that you're in the right direction. And this algorithm basically works on calculating the slope, calculating whether the error drops or not. If the error drops, it's a good sign. If the error increases, it means that it's a bad sign. So gradient descent is at the heart of learning, and many times when you're building model and such things, you have what is called as a gradient descent algorithm. Gradient descent algorithm. What is this gradient descent algorithm? Gradient descent algorithm is at the heart of learning in neural network. So this is what is called as a shallow neural network because there are only 3 layers. Many times what happens is that instead of having a shallow network, you may have layers and layers of hidden layer. Not one hidden layer, but you may have 15, 20 different hidden layers to learn a very, very complex pattern. And when you have multiple hidden layers, that is called as deep neural network. Deep neural network is the backbone of deep learning, and deep learning is in turn the backbone of artificial intelligence. So if you have only one hidden layer, it is neural network, it is MLP. But if you have 2, 3, 4, 5, it is deep learning. Right? The opposite of shallow is deep. So when you have multiple hidden layers, it is called as deep learning. Deep learning is the backbone of artificial intelligence. So artificial intelligence, may it be smart chat bots, or may it be robots, or many times may it be your smart cars and such things. This is the technology which is used to take action. It's just a piece of Python code or any other code that is written, which basically decides what action is to be taken. So far, is it clear? Are you able to understand what is neural network, why we use neural network, what is deep learning and such things?
Yes, sir, we understand.
Right. So this is the essence of deep learning and such things. So these things basically are, in today's day and age, it has become very, very powerful basically because our computational speed has increased, because the way we are our computational speed has become so powerful that we can operationalize this. Okay, so let me just show you. There is what is called as TensorFlow playground. Right? This is what Google has given basically. Can you see this basically? TensorFlow playground. Can you see this? Can you see this, please?
Yes, we can see.
So this is just a diagrammatic representation wherein you have the input features x1, x2, x3 and all, right? And then you have 4 hidden layers. Google has provided this. This is a good place for you to begin learning about artificial intelligence and such things. And you have the input features, you have the hidden layer, and then you have the output layer. So you have a set of orange dots surrounding the blue dots. What is happening is basically we are looking at the coordinates, x-axis and y-axis. This is your x1 and x2. And by changing x1 and x2, we are trying to get this shape. And if it is very close to this shape, it means that our output is clear. Now just take a look at this. All that I need to do is click on this, and you can see how it is trying to change here. You can see here the information flow. Based on this, it is trying to learn this particular pattern. Correct? Now, this is the hidden layer. Right now, you have 1, 2, 3, 4. Let us say, let me just help it by providing 5 neurons, right? 6 neurons. Correct? This is one more. You have one hidden layer. Now, if you want to one more hidden layer, you can just add one more hidden layer. You can have 4 hidden layers. This is the first, second, third hidden layer, and this is the 4th hidden layer, and this is the output layer. Now here, if you want to add additional neurons, you can add. If you want to add one more hidden layer, you can just add a hidden layer, right? So you can see here, it's a bit difficult to explain this because here the blue colors are the ones which are given weightage. Now at the end of it all, you can see here epochs. So when you run this, basically, it has run basically 157 or 200 different patterns to come up with this structure, correct? So learning rate is almost 3%. If you want, you can just change the activation function. There is something called as ReLU, sigmoid, or linear activation function. And to prevent overfitting, you also have what is called as a regularization technique. You have L1 regularization and L2 regularization. Any of these techniques can be used to learn this pattern. Many first problem is classification. You can also try a regression problem, right? Ratio of the training in the data set, by default it is 50%. You can just change the ratio here. Noise controller, you can use. Batch size also you can basically sort of change. So this is how basically you can just destroy some of these hidden layers, right? If you don't want, you can just destroy. You can just increase the hidden layer. You can just try a different L1 regularization, run this, see what happens, then basically change it to a L2 regularization and run this and see basically how the patterns are learned. So it's a good beginning. If you can solve a couple of problems here, it may look a bit childish, but it's very good that you can learn a lot of patterns here, right? So it is just coming very close. There are different problems that you can learn here, right? This is the first problem. You can learn a spiral pattern. Can it mimic a spiral pattern? So this is slightly more difficult. You can see here how the output is trying very close to learn this particular pattern. It is struggling a bit. So let me just increase the neurons. Let me just increase the hidden layers so that I can just help it more. I can just help it better, right? Just change the number of neurons. These are nothing but your neurons, right? These are nothing but neurons, right? So let me just destroy this one neuron, run this. Let us see whether it, right? It is trying to reduce this loss function, right? Loss function should be training loss is how much, test loss is how much. If they are very, very close to each other, it means that it is consistent, else it is inconsistent. See, it is almost struggling here, right? Just the inner thing itself, it is stuck and it is stuck in a loop, right? Maybe we can just be very patient so that it learns, or we can just Right. Okay, I'll just stop this. It has almost gone for 1000 iteration. Okay. So this is about neural network. Please try this. Right. So what I want to sort of show you now is another example. Let's just try to do this. Let me just remove all these things. I don't need any of these Word documents. We'll just be using R to build a neural network model. Let me go to my folder statistics and I have R sample files. Somewhere here, there must be a file which is called as binary file, which is not there. Okay. There is a file here which I wanted to import, which is called as a binary file. Okay. Okay, are you able to see this file?
Yes, sir.
So you have student, the first variable is basically admit. This is the dependent variable that we'll be using, whether a student is admitted or not. 0 means he's not been admitted and 1 means basically he's admitted. And which are the variables you have? GRE score is there, GPA score is there, and the rank that he secured. So based on the GRE, GPA, and rank, we are trying to estimate whether a student will be admitted or not. So you have around 400 cases, so that should be good enough for us to kickstart the process of modeling. I'll close all these things. Open up RStudio. Yesterday, what I opened was R. Now today we'll be learning about RStudio. Please tell me if you are able to see this.
Yes, sir, we can see.
Okay, so this is what is called as the RStudio. I've got the script window and the console window. Let me just start coding here. First thing is basically, let me look at the get working directory, which means basically where is the working directory located. Let me execute this. When I say get working directory, you say C drive users and then documents. This is where it is reading the files from. So let me just open my file. I may get an error here, read.csv, binary.csv. Okay, not bad. It is able to read the file. Okay, do you want to view the file in R? So just type view of data. So you've got 400 entries. Admit, GRE, GPA, and rank. These are the variables which it has pulled up. So far, it's clear. I've
Yes,
just imported the file.
Yes, yes.
Now, after importing the file, what is the next thing? So the next thing is to basically study the structure of the data. Right, it just gives a preview of the first 4 variables, 400 observations, admit, GRE, GPA, and rank. It is just giving a preview. Okay, it's good enough that we have been able to load. Now, one of the first things that we are going to do is what is called as max min max normalization. Any idea what is normalization here? I've loaded the data. I will have to do a minimum. I have to do a normalization here. What is the difference between normalization and standardization? Any idea?
No, sir, I don't have idea.
Sorry.
I don't have idea on this.
Okay. See, as I was saying, your GPA, GRE, and rank, they're all 3 different variables. GPA is there, GRE is there, and rank. These are 3 different variables. And for you to work on any of these three variables, when the input variables and their scales itself is different. So one of the important things that we do before taking them into the model building activity is to normalize them. When you normalize them, the output will always be between 0 and 1. I repeat, when you normalize them, the output will always be between 0 and 1. Another way of doing this is standardization. Standardization also you can do, but the output does not have any specific range. So let's just begin by normalizing my first input variable, right? This is the data pre-processing that you're doing for neural network. Yes. What are you doing with this minimum maximum? From each variable, you're subtracting the minimum value. Just look at this. GRE is there. From each GRE value, subtract the minimum, divided by max minus min of that particular column. Max minus min will always give you the range. So from each value, subtract the minimum value and divide it by the range, and you can store it as a new variable, data $GRE. Is this clear?
Yes.
Same thing I'm doing for GPA, and I'm going to do the same thing for rank. For these three variables, basically, I've been able to normalize these variables. So what is the effect of each of these things? So let us just see the effect. View of data. Are you able to see this now? 0.27, 0.1. Maximum value is 1 itself. All the values are more or less brought to the same scale, in the sense that they are now lying between 0 and 1. No value will be greater than 0. No value will be greater than 1. Earlier, it was very haphazard. Rank and such things are single digit numbers. GPA, GRE, all these things are basically, they're not really large numbers, they're small numbers.
Can you repeat once again, like how this you did the normalization process?
Can you see this data?
Yes, we are able to see the screen. Yeah, data we are able to see. Yeah, yes.
Let me just show this for one of the variables, how normalization works. Right, first thing is basically to calculate the minimum. Let me just look at the minimum value of this entire variable. Right, this minimum is 220. Now let me look at the maximum. Maximum is what? Max of this entire column. Minimum and maximum. Then let me look at the range. What is the range formula? Simple, max minus min. Maximum minus minimum value. So far it's clear? So far is it clear?
Yes.
Now if I want to normalize the GRE, it is very simple. Now for each value, that is 380 minus minimum value, you have to just subtract the minimum value. Now since I want to consistently, every value has to be subtracted by the minimum value. And then once you subtract it, divided by the range. Divided by range is what? Max minus min, which is 580. So you're getting the normalized value, which is 0.27. Are you clear with this?
Yes.
Now, if I apply the same formula here, right? If you just continue to apply, right, I should block C3 as well, right? $C, $3, because consistently it should divide by the range itself. Now you can see here how it looks. What is the maximum? Minimum is 0, maximum is 1. Every value here is being normalized here, which means to subtract the minimum and divide by the range.
Yes.
This is how normalization 0.27, 0.75. That's what I'm getting. Let me just compare it with R. You can see a 0.27, 0.75, so on and so forth. The third value is 1. We are getting 1 here. Is this clear?
Yes. Yes.
So this is how normalization works for all the 3 variables. Now, what's the next step? The next step is to basically partition the data set, right? Next step, let us just partition the data set. How do you partition? First, by setting the seed. Then by basically taking the sample. Just take a sample. Right? See, sample, I need 2 samples based on rows, right? 70% I'm just taking for training and 30% I'm just taking for test. I'm creating an object which is called as IND or IND. Now, let's just do a training data set. In training, basically, IND equal to 1, which means that the first value will go under training data set. And for testing, basically, I'll be taking the remaining 30% of the cases. So far, is it clear?
Yes. Yes.
I've created the training data set and the testing here. That's it. What about the others? Is it clear?
Yes, sir.
So at this stage, I've got the training data set. I also have the testing data set. Okay, what next? Right, in your typical, what shall I say? Python, we use the train test split. Now here comes the neural network, correct? Install.packages of neural network. I have to I have to call the library. I have to call the library, and then basically I have to set the seed. This 333. This is how your neural network would work.
Sir, what are these 222 and 333 in seed functions of this?
Yes, this will ensure the same set of cases are picked up every time you repeat it. So you are taking a sample, correct?
Okay, sir.
In a data set of 100, let's say you're taking a sample. Now forget 100. Let's say if you have 5 cases, I'm just giving a very simple case, a simple example. Let us say you have 5 cards and you pick up a sample. In the first instance, you may have 1, 3, 5. These are the 3 cards you may get selected, correct? In the second instance, if you just shuffle these cards and pick up a sample, do you think you'll again get 1, 3, 5? You may get 1, 2, 3 this time, correct?
Yes, sir.
Yes, so third time you repeat it, you may get a different set of records. The same way, what happens 100 times you take a sample, you may get 100 different combinations. Now, what we are doing with set.seed is it can be any number. Each time you pick up a sample, the same set of records will be picked up. That is 135. Let us say you shuffle and then again pick up the records 135. The same set of cards will be picked up.
Okay.
So that is the idea behind setting the seed. Now, the next step that I would like to show you here is as follows. we come here. We freeze the screen. Okay, so that you don't get distracted with word and such things. Okay. Now we are going to build the neural network model. Neural net, this is the function admit $GRE plus GPA plus rank. This is the sum of the independent variables that you're taking. This model will be built on training. Hidden equals 1. Any idea what is this hidden equals 1? Hidden equals 1 means basically there's only one neuron in the hidden layer. Yes, there is only one hidden, there is one neuron in the hidden layer. One neuron. Right? Error function is what is called a CE or cross entropy. This is your N. Right? We have built a neural network. Let us just try to plot it. So using plot of N. Can you see here? This is how your neural network function looks like. Correct. We have done a very quick and a dirty job of building a neural network. This is the input layer, GRE, GPA, and rank. And you can see the weights that are being estimated for each of the input layer. And when you take the sum product of GRE versus the weight here, GRE times 0.82 plus 1.3 times GPA plus of minus 0.87 times rank, you have to pass it through the hidden layer. Correct? And this is the bias term. 0.045 is nothing but the bias term. When you further take the bias term and get the final output here, you'll get a total value of 8.7. This is one more bias term which is passed into the admit layer, and then you are getting the output. So in this estimation, it has run how many steps? 11,977 iterations it has been able to do, and the final error value is 161. So this is the baseline model of neural network. Now the question is, can we beat this? Can we reduce the error through some other techniques? Correct? If you can modify it, you can refine it and reduce the error, there is nothing like it. But if you are not able to modify it, that's when the problem is. So far it is clear?
Yes, yes.
This is how the hidden layer works. Now that we have done this, let us just do a prediction. Right? Compute N. N is nothing but a neural network. Training of -1. Let us just pick up one record and look at what is there in the output layer. Look at this. For the first record here, right? 0.75 point GPA and 0.81 as the GPA, 0.66 as the rank. This is the value. Okay, this is the value. Look at this. The predicted value is that there is a 37% chance that he is admitted. 0.37 is basically less than 0.5. So there is a less than 50% chance that he's not admitted. 1 means basically admitted. Had this number crossed 50%, we could have called that he's admitted. So this fellow will be classified as not admitted. Next fellow is classified, there's a 66% chance that he's admitted. The fourth fellow is saying, the model is saying that there is a 14% chance that he's admitted. So it's estimated the probability with which a person will be admitted. So far it's clear?
Yes, sir.
This is your output. Then basically you can look at the head, right? If you look at the head means basically the top 5 rows. Look at the top 5 rows, 37% chance that a person is admitted, which is very low. 66% is greater than 50%. So you can say that yes, the second fellow will be admitted, third fellow will not be admitted, fourth fellow will not be admitted, he will not be admitted, and the ninth fellow will also not be admitted. So this is how the output comes out. Okay, let us actually look at the class. We are saying here that the first fellow is not going to be admitted. But what is the actual class? The actual class is that he is admitted one, which means our model is lying to us, it is misleading us. The very first record is a false record. Is it clear?
Yes, yes.
Okay, let's just make a move on. Let us look at the node output calculation. What is happening in each node here? That is what we are trying to estimate here, right? For the first record, we are getting around 0.37. How is it arriving at 0.37? Look at this. Some numbers I have to change here because it is in the earlier output. Correct? Input 4. See, this is the first circle, which is node 1, node 2, node 3, and this is the node 4. What is actually happening in node 4, and this is node 5. That is what we are trying to calculate. Can you see here? It is written in blue 0.0455. Correct? That is the bias term. The same bias term we are writing here 0.0455. Are you clear with this? I'm just showing you in each node how what is happening. Is this clear?
Yes, yes.
Now then you have 0.82, which is the estimated weight for GRE. That 0.82, I'm just writing here. Star is multiplication multiplied by 0.75. Where is this 0.75 coming from? The second fellow's GRE score is 0.75. Is this clear?
Normalized term.
After normalization.
Yeah.
Because all the values are, you can see here between 0 and 1. So this is a normalized GRE score. Put a plus sign here. Here it is 1.351. That is the estimated weight, which is what I am writing, multiplied by 0.81. 0.81 is nothing but your GPA score. Then put a plus sign here. Then you can write minus 0.87 multiplied by 0.66. This is the rank value. So is it understood? Bias plus sum product of the weight times the variable. So what is the value here that you are getting? You are getting some value, which is, when I execute this, you are getting IN4. Now, what is this input 4 value? Input 4, if I just print out, you are getting 1.18. Are you able to understand this? So at this stage, we have a value of 1.18. Correct? This, after taking the sum product, what are we going to do? What is going to come out of the output node 4? You have to pass it through a simple exponential function, through a simple sigmoid function. You are getting it as output 4. Now this output 4 basically, right? So 1, 2, 3, 4. What has come out of the output? That's what we have to now do. 8.574. This is the value multiplied by output 4. This is the output 4 plus of, look at the bias term here. Look at the, it is minus 0.706. When I execute this, you are getting input value of 5. So what is going into the input for this node is, let me just print this out, IN5. What is going is nothing but 0.49. It is going a value of minus 0.49, minus 0.49, right? Let us see what is the output value now, right? What is the output that is going to come out, right? That is what we are interested in. Just do an exponential function. In the exponential function, I'm just writing it as, not exponential function, sorry, I'm using a sigmoid function, 1 divided by 1 plus exponential of minus input value of 5. So now when I execute this, you are actually getting output value of 5. What is the output value? 0.37. Now this is how the first person's value is admitted as saying 37% chance is there that this fellow will be defaulting. Did you understand how 37% came? Look at this. This is the 0.37 or 37% chance of him being a defaulter. That's how we have estimated it. Did you understand that calculation?
The calculation, it is little straightforward, sir. How this bias values 0.0455 and minus 7.061 came out into the picture, sir? Like
This is
how
just
they
like
have
your
they got
this is
generated?
this is just like your intercept term in regression.
Okay.
It's just like the intercept term in regression. That's it. So far, I hope it is clear.
Yes.
Okay. Now, when you build this model, finally, you have built up a model with one neuron in the hidden layer. So let me just run a confusion matrix. In this confusion matrix, right, let me compute meaning of -1. Let me print the output. This is your P1. We get the predicted value. Then let's just look at the table value. Tab 1, right? What is this tab 1? See here, this is the model with one hidden layer, right? And one neuron. 0 versus 0, 172. I hope you can see this. 1 versus 1 is basically 26, right? So in identifying basically the students admitted, our model is right 26 times, correct? So the overall percentage of accuracy, if you have to calculate, it is simply diagonal elements. Take the sum of, it is 172. If you add it up with 26, you'll be getting 198. 172 plus 26, which means basically the diagonal elements I'm adding, which is 198. That I'll be using as it is. In the denominator, I'll just be taking the sum of all the cell values, which is 172 plus 66 plus 17 plus 26. So you get 70% accuracy. So our neural network model, which we have built for the very first time, is giving us a 70% accuracy. Is this clear?
Yes.
This is on the training data set. Now you can sort of do the same thing on the test data set. In the test data set, basically, it is just 29%. When you do 1 minus sum of this, right? So when you do 1 minus sum of this is the error term that is that we are getting. So it is better to just do sum of. That is also better. So it is 70% is the accuracy of the model. On the test, 71 and 70, there's not much of a difference. So the model is quite robust. That's how you can conclude it. Are you able to understand this?
Yes.
Okay. Now this training we have calculated, testing also we have calculated. Now what we are going to do is basically the same hidden, we are just going to increase the number of hidden layers, correct? Earlier we had only one sort of hidden layer. Let us just do what is called as hyperparameter tuning, right? So here we are going to increase the hidden layer to 5. Earlier, how many hidden layers you had? Only 1, right? 1 is basically a very simplistic case, but we need to have, right? Hidden layer was 1. Now basically instead of having 1, basically we are increasing it to 5 hidden layers. So this is how the model now looks like. You can see here 1, 2, 3, 4, and 5. You have 5 different hidden layers, and this is the output layer that you have. You can see here the error has, when I'm using 5 hidden layers, the error has dropped to 148, which is a good sign, which means that the more number of neurons that I'm adding, earlier, if you remember, the error was 161. 161, it has dropped to 148. Correct? So 161 minus 148 divided by 161. So if I do, okay, maybe I should do it like this. 161 was the original value. Around 8% reduction in error is there when you increase the hidden layer. 8% hidden layer. Right? You can experiment with different number of hidden layers. You can increase the number of neurons and such things. Now, for the same thing, what we can do is basically, I can calculate the confusion matrix. I can calculate it for both training as well as test data set. So let me begin by calculating what is the error for training. 28% with 5 hidden layers, 28%. The testing, what is the error value? 38%. The testing, there is 38%. So there is some gap here, which means there is some level of inconsistency between training and testing, right? 29% and 28 and 38, almost a 10% gap, which means that if you're using hidden layer, 5 hidden layer, there is some level of overfitting that is present. You can't have too much of a gap there. So far, it is clear?
Yes.
What we have done so far is just a neural network. Now I'll be moving on to what is called as deep learning, right? Now, as I said here, so far we had only one hidden layer. Therefore, it is called as a shallow network. Now we'll be learning deep hidden layer, deep neural network. So same thing, there is no change in the functions and such things, correct? Except that in the hidden layer, C of 2, 3, which means that the first hidden layer, this has 2 hidden layers. The first one has 2 neurons and the second one has 3 neurons, right? First one has 2 neurons, so it is taking some time to do the computation. This is not so easy for it to compute. It is just taking some time. Now, if you want, you can just plot the neural network by saying plot of n. You can see here how it is working. Input layer, hidden layer. The first one has 2 neurons, and here you have 3 different neurons because we had given 2, 3, and this is the output layer. I think there has been some decrease. 146 is the error, which is a good sign that our error should keep reducing. Our error should not go up. It should keep reducing as much as possible.
Sir, couldn't able to see the plot, sir.
Are you able to see this now?
Yes.
Yes, sir. Yes, sir. Yes.
This is the, yeah. How you are able to see?
Yes. Yes. Yeah.
This is the new one. Error is 146 here. Are you able to see the new plot or the old plot?
The new.
With 146 error, correct? Okay, for this
No, sir.
module,
Probably I am seeing still 161 only.
now are you able to see?
Yes. Yes. Now it is showing 146. Yeah.
This is 146. So the first hidden layer has 2 neurons, second one has 3 neurons. So slightly complex looking neural network.
Yes. So we can have some more discussions tomorrow, and we can have some repetition also, because this seems to be a bit complex, the model.
Yes. Okay. Let me revise the neurons in the hidden layer. Now, what happens is basically I'm just changing, right? Now, just by experience, I'm just telling you, never give it in ascending order. 2, 3 is usually the solution will not converge. There will always be a problem. If the first hidden layer has fewer neurons and second one has more neurons, that's a problem. So it is always better that you give it as decreasing order. First one has more neurons, second one has fewer neurons, that's always better. Usually the solution will converge. Now let us just look at the performance evaluation of this model here. So confusion matrix P1 predicted. Let me just do the table value. So 26% is the error. I hope you can see this. 26% is the error when I've changed it to 2, 1. So like this, you can keep experimenting with the different hidden layers and such things.
Okay.
So in the training, I got 26%. In the test, let me just see how much am I getting. 115 onwards. 26% again you are getting. I hope this is clear.
Yes, yes.
Which is a consistent model. In the training and the testing, if you are able to get the same thing, there's nothing like it. It is consistent. 100 minus 26, we are calculating the error. 26 is the error. So 100 minus 26 is how much?
74.
74. So approximately 74% is the accuracy, which is a reasonable model. Correct? Now let us say you want to repeat these calculations. Right? So we are giving a repetitive model. You can just see here. So I'm just saying rep equals 5 here, which means that the neural network will give you 5 different repetitions. You can just see here how it is converging. Can you see here? It is just running 5 different repetitions of model it is giving us. Neural network, first one, second iteration, third iteration, fourth iteration, and fifth different iteration. Okay, now you're getting the repetition. So error in if call argument is of, sometimes you may not get the error value if the solution has not converged. Let us just see here from the top. So there are 5 iterations that we ran. Let us see whether what is the value of error that we are getting. Look at this. This is the hidden layer. A repetition 1 out of 5 steps. Okay, so it is just going to display the error. The error is 149. You can just see here, this is the final value of error that we got. The solution converged. Therefore, it is displaying the error. If the solution would not have converged, it would not display the error. Repetition 2 out of 5. Let's look at this. 149 was the error. Repetition 2. If I scroll down, see the error is 143. So which means that this is better, right? If you look at repetition 3, let us look at the error value here. Error value is 147, which is not as good as the second model. Second was the least, which is 143. So the best seems to be repetition 2 with error of 143. Now the error has finally reduced to 143, which is the fourth iteration. And therefore, finally, if I look at the fifth iteration, so fifth iteration, you're not getting any error at all, which means that it has not converged. The solution has not converged. So only the first four iterations have converged. And therefore, you can say that the first four solutions you can consider. The best out of the first four iterations is basically the second model, because it is giving you the least error of 143. So this is about the model. So here, if you want to plot, you can just specify the repetition number. Is it 1 or 2? You can just specify. Here I'm just taking the one repetition 1, right, which is giving an error of 155. I can just change this to 2 if you want. Correct? Rep does not exist. Repetition does not exist. Okay, 3. Okay, there's something wrong here. Repetition 1 exists. Okay. 5 repetitions. Usually by specifying the repetition number, it should produce. Okay, let's just go by the default of 1 itself then. If you want, you can just run a help function of neural network. So you can just see here the different ways in which you can build a neural network model. R displays all the different arguments and such things, step max, rep function, learning rate, life sign. Right? Error function is there. The different values are also basically displayed. Algorithm is basically rprop plus. This is one of the methods. You can also use backprop. Then you can use rprop minus. Then you can either use sag or SLR or backpropagation, right? Rprop plus and rprop minus refer to the resilient backpropagation with or without weight. So rprop plus, when you use, these are the different hyperparameters which you can experiment with, right? Rprop plus you can use, which means resilient backpropagation with weight backtracking, or you also have without backtracking. Minus means without backtracking. What is the SAG and SLR? Induce the usage of the modified globally convergent algorithm. Okay, different algorithms basically. Finally, for this repetition one, let's just look at the error terms. Let us see the error term for both training, output P1, predicted one, tab 1 again. Error is 26%. Somehow we are stuck in that loop of 26%. We are not able to better it. Right. So here, basically for the test one, let me just run the neural network output. I'm getting 26% itself. Well, so that is the model, right? Now, so far we have played around with what hidden layers only we have played. We have experimented with hidden layers. We have not experimented with some of the algorithms. The default algorithm, just now you have seen, is resilient backpropagation with weight estimation, correct? So you can just change around with change this with respect to rprop plus, rprop minus, all these things you can just do. You can just see here, neural network error function is CE, but algorithm I'm changing to rprop plus. Now we can just run this. Okay, there's a lot of error here. Step max function, let me just increase it to It is not running this error. Let me just try with rprop minus. Okay, the error exists. Okay, but what I'm trying to say is, for some reason, I'm getting some error. Unexpected. Okay. Hidden equals 1. Okay, hidden equals 3. Repetition 5 is a problem, I think. So let me just run with repetition 1. Repetition 1, it is not taking. So let me just delete this. Rprop plus only shall I give? It is not running for some reason. Okay, with 1. Some problem with step max. So let me just remove the step max. Finally, it has run. Okay, I think the problem was with the way I'm using the bracket. Okay, so we are using a resilient propagation method. We are saving it as n, right? Rest of the things will remain the same. But what I need to do is basically run the confusion matrix for both training and test. Control C, the object is changing. So from line number 160, let me execute. Line number 160 is here. This is the output P1, predicted 1, tab 1, tab 1, and then 1 minus. So 29%. So by changing the algorithm, there is no improvement. There's only worsening of the performance. Right? We have to experiment. Unless we experiment, we don't know which one is the best model. 29%, it is going from bad to worse, correct? So this is how you can change the algorithm and experiment with different types of algorithm, right? Rprop 1, Rprop 2, minus, SAG algorithm, correct? So these algorithms you can just refer to using your help option in R. Okay, so any questions you had? Any questions you have?
Mithun sir, we can, yes, we have questions. Like, I think maybe we require some repetition into this, the model. So maybe like if we can do it, some part of it tomorrow, so that will be better. And if anybody is having any questions, can put up to. We have today also invited Dr. P.K. Mishra. He is waiting. So, sir, welcome, Dr. P.K. Mishra. So maybe there is a short session of Mishra sir will be taking it. Okay, once you finish it off. So, sir, yeah. But any questions will take up, and also we want that I think tomorrow we'll cover up that in the beginning. That especially the confusion matrix we did. Maybe we can do with some more examples.
Confusion matrix, I think we have covered already in logistic regression. It's the same thing.
Okay.
But anyway, if you want me to explain, maybe tomorrow I can explain.
Yes, sir.
Okay, any questions, anybody? Any questions, please ask.
So, if there are no questions, I think, sir, should we now will take up for tomorrow? They will invite Dr. P.K. Mishra, Mithun sir.
Yes, sir. So thank you very much.
Yes, sir. So thanks a lot on behalf of all our participants. Mithun sir has explained the neural network and the deep learning today. So we are thankful to you, sir. And we'll be again meeting, and we'll have more clarification on this neural network and deep learning. Okay, sir. Thanks a lot, sir. Thank you so much, Mithun sir. Yeah.
Thank you very much. Have a good day. Bye.
Yeah. Good evening, Dr. P.K. Mishra.
Yeah, good evening.
Sonal, can you formally introduce Dr. P.K. Mishra? Sonal, are you there?
Yes, sir. Am I audible?
Yes, yes.
Yeah, give me a minute. So am I visible?
Yes, yes, you are visible, Sonal.
Okay. So good evening, everyone. I would like to take the privilege to introduce Dr. P.K. Mishra. Dr. Mishra has over 30 years of experience in the IT industry and academics. He has rich experience of working in senior management and leadership positions of prominent MNCs, along with substantial involvement with mentoring, entrepreneurship, and teaching. Presently, he is associated with two startup companies. He has worked in areas of operating system, middleware, interoperability. His contribution to open source software and Linux has well acknowledged. He has led many system software product engineering and consulting projects while working for iconic technology companies like Digital, Hewlett Packard, Novell, and Sun. He began his career with National Informatics Center and headed their system software division for many years. His current interests include data analytics and use of AI and ML. We are glad that you could join us, sir. Over to you now.
Okay, good evening to everybody.
Good evening, sir. Good evening.
I believe, my topics will be a lot more lighter. I think I think going from mathematics to really a little bit of, logistics and how really, I think what really goes behind the AI this scenario, particularly for teachers, that is what we'll look at. How much of time we have, Dr. Shukla? About half an hour, or it can be little more?
I think half an hour, if you can.
I,
Yes.
I have really no problem. My
Yeah.
slides can be shared. My slides are more in a
Yes, sir. Yeah. Surely, surely.
problem. But anyway,
Sure.
I'll try to stick to about 30 to 40 minutes max.
Yes, sir. Yes, sir.
Is it visible?
Yes, it's visible. Yeah, yeah.
Shall I make it full screen, or I think you are able to see the screen properly?
We are able to see, sir. We are able to see.
Okay. Okay. Good evening to everybody, participants. I'm sure. You had a lot of discussion on AI and ML. What I would say that is the horizontal part of the technology. I think the horizontal part is whatever you are learning can be applied to any domain, any vertical that you may be interested in. I'm sure. I think the horizontal part of the technology learning is something that has to be done by you people who are going to teach students. Downstream. But I think in my part of the talk, I think I'm not really going to talk about the horizontal part of the technology. I'm going to limit myself to the vertical, that is the education sector. How IT this thing today, what we are looking at AI and ML as a new subject, as a new set of technology points can be deployed for classroom and for mass education, which are real this thing. I believe a lot of things I will be talking about, but they are probably not happening today. But I think in the next few years, you will probably be able to see all of that in happening inside your system. I believe I'll be little bit, because my talk was structured for about 1 hour to 1.5 hours, because
yes,
time less. I would be little jumpy, but anyway, I'll still touch upon many of these things. These slides that I will be sharing through Dr. Shukla, you can always get them, and they are more like a handout kind of thing. You can always read it and add your thought process to that one. Our agenda is top trends in education and learning landscape. All of you are teachers. You probably have seen all of that, but I think I have put it in one place, how it looks like from an expert's point of view. Use of artificial intelligence and other complementing technologies like augmented and virtual technology reality. I think this may be relatively new to some of you, how they can be harnessed to improve the outcome of learning. That's what is one of the outcome of the learning. Improvement is one of the biggest agenda in our country, in fact, anywhere in the world. In our country, it is little more because we probably have other resources which are we are constrained, and how to improve the outcome is a bigger challenge for us. We will probably look at a little bit of primer of the technology components. Probably, I think I will skip this part, this thing, because you have gone through a fairly good amount of rigorous this thing. I mean, technology components. I will just touch upon those things, and we'll look at a few use cases and how it can be used in the context of a classroom or a learning platform. I will also suggest a few contemporary tools that you can consider to get started. You can always pick up the right ones for you and use them to your convenience. Well, a little bit about myself. Why I'm showing this slide is because I am not a pure play this thing. I'm an industrialist, or I am not a pure play academician. I am more of a hybrid kind of person. I have done a lot of hands-on technology. I still write a code at least about 10,000 lines of code in a year. That's what I write. I tell people. So it is. I have been a excellent manager and good for my company. I also keep talking to students and teachers fairly often. So I think I'm more of a hybrid kind of person. So I think what I'll be talking about in my slide is a confluence of many of these experiences that goes into the topic. What is our approach? Being a FDP, all attendees are teachers, and all of us try to improve the outcome of learning. Teaching the teachers is not really easy, but hopefully, I'll be able to motivate you to look at some of the areas which are relatively, unattended or not well considered, and you can take it forward. Let us look at, some of the confirmation. I think let us not get carried away by just the word AI and ML. I mean, it appears exotic. A lot of people who are very tech minded, they probably love to jump onto this bandwagon and really try to make it happen for themselves and for their students. But there are a lot of things in the tech education or top education technology that we need to imbibe to our classroom and our overall learning. Tech and data-driven analysis of the students. This is what is easier said and done, but this is one thing which really most of the colleges and universities, they are already doing. Video-based learning, I think it is reasonably common, and after in the last 2-3 years, it has become, with online teaching and all, it has become commonplace. Virtual reality, it is something which is going to come in a big way with the metaverse technology being going to common in the next. Which is already probably common. People who are using the platforms like Facebook and more serious platforms, virtual reality based platforms have been imbibed into education technology. We also have a lot of IoT deployments, particularly for sensing the students' understanding of the topic, the classroom, and the digital transformation of the education platform. Online assessment, I think it has been happening. Chatbots, it's well understood. How it can replace some of the entry-level tasks that teachers have to do. Artificial intelligence, you have been learning. Podcasting, self-paced learning. These are some of the, the teaching community has to put all these technology components together in order to improve the outcome of the education for the student community. Okay, why study AI at all? I think I don't have to explain to that, but I think in a very short form, it is an ocean touching all aspects of our modern living due to unstoppable digital transformation. Digital transformation is happening. The previous slide, we talked about a lot of these technology components. They are all helping for a digital transformation. And AI is just one glue in that, and that has to be rightly deployed to have a trouble-free or a successful digital transformation. And what could be relevant to the education sector? That is what we are going to see in the next few slides. Talking about a little bit of, AI is not an end in itself. I believe the IEEE computing age identifies some of these topics for the last couple of years. Our students, they really have to pick up one of these and probably go and get learn it and go and get a job in the market. And I think in these slides, you will see that artificial intelligence finds a prominent place, and it is also going to be of this slide basically confirms that we are on the right track. But AI alone is not going to help everyone. You can few other things are there. You can always add them to your teaching curriculum to make things good for your students. Okay, let us look at this thing. This is not mundane. Some of it may appear to be very appealing to common sense, but some of these things can still be deployed, and we haven't done that much in India yet. Learning becomes interesting. How technology can help in education. Learning has to be more interesting for the students. A lot of students, particularly the class which is a little bit in the deprived class, they don't find learning or classrooms very interesting. We have to make it interesting for them. Mass learning should become easier and less dependent on teachers. I think we people as teachers, we want to be to feel good about that people like us, this thing. But the fact remains that there are not that many good teachers. There are not that many teachers. Forget about good or bad. We don't have even that many. So we need to use technology to have a mass learning program so that everybody at least comes to a stage where that minimum learning, minimum education is available for everybody in the coming generations. We have to break the barrier of time, place, and mood of the teacher or the learner. We have to integrate the classroom, experiment, and skill practices. All three of them today are getting done at 3 different places. It will be good if we have an integrated approach to all the three, so that at the same time, all the three things can be useful for the students. I believe the best part of learning is ability to have better quality of problem solving ability, or ability to solve problems in a better way, collaboration and group learning. I believe these things are probably not as yet good. In our education system today, we still have system people come with 95% marks, but still they probably lack in many of these things in a big way. We need to improve all that. We need to assess the large volume of students, evaluate them, and if possible, customize learnings for all of them. Availability of books, libraries, and labs, they are already scarce resources. Books are probably going away, but still, good books. You don't get them on the internet always. You need to have a facility for good books, good libraries, good labs, apart from good teachers. Last point in this slide is how to really integrate the emerging new technologies into the digital transformation at the education in the education sector. We will be seeing a little bit of that in the coming slides. I'll skip that one on this slide, but let us see some of the characteristics of artificial intelligence. I'll be repeating it. It enhances business productivity. It goes without saying. I believe a lot of these things that we are going to do by hand or conventional methodology, they probably will become easier if we can automate them. I think the error-prone tasks, processes, and workflows, if we can automate them intelligently, then we'll get a productivity in the business or house or in the industry, whatever is that. Data ingestion. That is a very important thing. Today, we do collect a lot of data, but they are not really put in the right way for, use. Data cannot be used. All the data that we collect, we cannot put into that. So we have to have right processes for ingesting data into our existing systems so that they can give you meaningful models, meaningful outcomes, meaningful, input for decision making. The third point in this slide is I believe we would love to have machines to have some kind of a cognitive ability similar to the human beings have got. That is easier said than done. I believe for the last few decades, we have been trying to improve the cognitive abilities of the machines, but it is only recently, only now in the last 4, 5, maybe last decade only, we have seen a great improvement in the cognitive abilities of the machines or devices, and they are going to improve by leaps and bounds in the next few years. And we have to really, make use of them in our education system. This slide, I believe all of you know, what is the real difference between a human being and a machine? A human being is one who probably uses a lot of heuristics to do a problem solving, whereas machines use algorithm or processes in problem solving. All of us being teachers, we really have to teach our students or the next generation how to really improve the heuristics part of it. I believe a lot of times we talk about algorithms, talk about artificial intelligence, talk about machine learning. We are depriving ourselves the God-given ability of problem solving by human mind. I believe as teachers, it is our job really to imbibe the right way of learning to solve problems by using our own thinking or heuristics. That is actually the baseline based on which the algorithms have to be created and things like that. So I believe here I have a contrarian view in this slide. We did not be completely sold out to mathematical modeling, whatever algorithms this thing. There are, dozens of algorithms which have come out with various flavors. They can solve. They can do a modeling, they can give you an outcome, but I think that is, as a teachers, we need to enthuse our students and the next generation to solve problems and be a torchbearer for the generating newer algorithms. I believe this is a little contrarian slide, and we should remember this while we do AI/ML, learning or teaching. AI universe, I think this slide, all of you know that where all it is getting, deployed, how people are making things a little easier for themselves. So we'll go to the next slide. I believe you are already in your classes, you are talking about AI, machine learning and deep learning, neural networking was, how to use that. My previous speaker was already talking about it. So we'll drop. Okay, this is a slide which again, as a teachers, we need to really do that. I believe in our enthusiasm to really learn about AI, we just, probably neglect some of the enabling technologies which are below that. The enabling technologies which are about, I believe we need to teach our students about, GPU computing is one of the, high performance computing, GPU computing, these are not probably getting as much of importance they should be getting. Everything is not done by R, everything is not done by this thing, packages similar to R. We need to really, have some understanding of what are the enabling technologies, GPU computing, IoT, big data, algorithms development, and APIs. These are should go hand in hand while we try to learn some aspects of the API which are probably given in the upper part. Cognitive computing, computer vision, natural language processing, neural networking, deep learning, machine learning, all these things. They are, big topics by themselves. While we spend a lot of time and energy in learning these things, we must enable ourselves about the enabling technologies and guide our students also to understand some of those things. That will make, otherwise we become a slave for one kind of, I personally feel a lot of these things, they have been straitjacketed or modeled into one way without giving a facility for fresh thinking or fresh way of doing things. Artificial intelligence is not just by using somebody's, somebody's written path. We have to create various paths for solving the same problem, probably in an intelligent way, and to probably invent newer ways of doing things. And these enabling technologies, in a way, they are essential for a better way of learning. Okay, let us see how digital media really helps in our education. This digital media in the modern digital world is essential to enhance the raw reality with the digital reality. But how? What do we do? I believe many of you would have really come across situations where virtual reality is used. Virtual reality is actually one of the immersive systems where in the plain simple, what you observe, that can be slightly jazzed up, probably with a three-dimensional or 360-degree view to make you feel, what is all in the totality, not just a picture or just a symbol. Augmented reality is something where I think we take a conscious effort to add digital, facets to an existing object to augment the reality so that it can be understood or it is given, it is really felt in a better way. Mixed reality is something which is the reality. I believe, the metaverse that we are talking about today is actually a combination of this kind of mixed reality. This slide tries to do a little bit of distinction between what is virtual reality and augmented reality. I have already made a mention of that. Virtual reality is an immersive experience, altering your perception to make you feel like you exist in that particular world. You go to a zoo, you go to a museum, you go to undersea. What you feel. I think that is just not a two-dimensional understanding. That's a multi-dimensional understanding. Virtual reality helps you to go that. If you want even more enhancement to your senses or feeling, you can probably by sitting at home, you will be able to get all those feelings by creating an augmented reality. I think people who are advertising things to you, they are already using it in a big way. And I believe one should, as these components, they enhance the AI system even better. I think this is a slide. It's a very dense slide. I think for teachers, it is good to understand this one. But I'll spend just a minute because of lack of time. I believe what really makes our learning useful. How do we make the learning? Retention of learning, how do we really communicate a very complex subject to people who may not be so good at understanding of things? Learning and the retention to learning, these are some of this is the pyramid. And I believe in this audiovisual part of this thing is something which is very essential. The audiovisual part of the learning, when you add with the remaining of the AI-based infrastructure that the students and teachers they are going to use, it is going to make it even more effective. AI tutors. I believe teachers, they can spend only that much of time with a student. Usually in a classroom where there will be 30, 40, 50 kids or students, a teacher's time cannot be given to anyone. You have students who are to be below average, you have students who are average, who are good students. You need to cater to everyone, each one of them. So I believe it is easier to engage an AI tutor for a lot of the basic stuff in any subject with support from audiovisual extras. Explanations and details are provided depending on the student's capability. I believe these things should be immediately put into practice so that we have, our already thin teaching community that can improve their output and they can really reach out to a much larger set of audience. Chatbots, they're already used in some kind of progressive systems. assessments, etc. They have been largely computerized or automated. In the Indian context, we need one more extra with that one, because India is not one country with one language. I recently see that a lot of people, for whatever reason, they are rising up against English, which probably not the right thing to do, because it was one of the unifying way of learning things in our country. But you can't complain that. I think everybody has uses a native language, and in India we have too many native languages. So I think the NLP or natural language processing features that we already have with us, or we are already improving, we should be able to use that to improve the learning outcome for large majority of people who may be not interested in knowing more than one language. Education assistant, I believe a lot of existing digital assistants are today there. Alexa, Apple Siri, these are some of the well-known digital assistants, but there are a few others which can always be trained better to be useful for the teachers. I think in conjunction with the smart boards and remote teaching, using some of these digital assistants will make the teaching a little more easier and more interesting for the students, and probably help to customize depending on the requirement of a particular student. Again, I believe making learning interesting. I believe this is again a dense slide. I will just say that using AR and VR, augmented reality and virtual reality, we will be able to make learning interesting and probably provide a 360-degree way of understanding complex topics which can not be easily communicated to the students in a quick time. I think what you can communicate in probably half an hour, if you use audio visual, a combination of all the available digital media, you can communicate far better, and probably you don't have to even bring all the students to the class. This also helps to have a integrated approach to these things. At the same time, I believe while the teacher is teaching, he can do the lab work. He can also show them how these skills can be learned in a particular situation. So I think making learning interesting using the new technologies is an interesting part. How do we help the human teachers? I believe all the combination of all these things, the teachers today have a tremendous amount of workload with them. They have to create content for their, a lot of content is available today on internet elsewhere, but still when you are going to teach a class, you have to be ready with your own content. You might have borrowed a part of the content from somewhere, but you still need to make it appropriate for your class. You handle large classes which have got uneven student mix. There are top tier students, there are bottom tier students. You have to be useful for both of them. Personalize the content for every student. If not for every student, at least you make the students into 2, 3, 4 different categories, and you try to give them what actually they need or how much they need. Proper evaluation and feedback takes a lot of time for the teachers. The teaching workflow is getting more and more difficult and is not really properly automated. All these things, they can be, newer digital technologies can be used. I believe to the extent you need to put digital technology into this one, how much you deploy will be dictated by back-end processes which can be driven by artificial intelligence and model building. Then we come to a case of students who need special, who have special needs. I think this is another area where education system has not been very appropriate. A lot of students with challenges or who don't have the, the challenges can be physical, can be mental, can be situational, whatever is that. differently able students, bringing new challenges for the teachers. But I believe if our system is ready with these newer tools, this thing based on artificial intelligence and those media enhancements I was talking about, you will be able to handle many of these students who are otherwise not getting into the education system or not able to leverage the existing things to their benefit. So let's see, where do you start? I believe all these are probably, I think, to an extent articulated reasonably well, but where do you start? I believe all of you have already started in a way. I mean, most of you who probably come with a little bit of, computer-oriented background, you know certain amount of programming. You can use Python, you can use R, you can use a plethora of tools available on your machines to learn about the horizontal part of the things, AI and ML. But really trying to put them into a particular discipline, that is what requires a little more extra that you have to discover for yourself. Platforms like AWS and Google provide a fairly good amount of free and affordable subscriptions to learn, experiment, and build solutions. I would strongly suggest that please explore all those things. I mean, many of these things that the teachers are learning today, they don't should remain the classroom oriented. They have to be really deployed as it should be in real life. And if you look at the companies, I think, there are a large number of, well-known companies who are doing pretty good job. And I think their websites, they have very rich resources to help the teachers to go forward. I mean, to take just a few names, IBM, Intel, NVIDIA, Microsoft, all of these, they have very rich resources available from them to do that. I think government of India itself is doing a lot of hard work to take AI to the masses. Those of you who haven't seen that one, please see this indiaai.gov.in. I believe they are very frequently, they organize seminars and they try to communicate what is really good quality material for people who are interested. I think it is free of cost. All of you can have a look into that one and benefit out of it. For educators, where do this thing? I believe most of you are already well started, so this slide will drop. It is, I think all of you have reasonably good resources in your institutions. And add to that, as I said, this industry, what it gives you, particularly, Google and Amazon, I believe if you look at their sites, you will be pretty fast. You will become competent to do that. Another thing, if you are really going to use this thing, VR and AR, please look at this site, unity.com. It is, programming on unity.com is pretty comfortable. If you have access to Visual Studio, please go ahead and do that. They will, in whatever you are learning on AI, if you mix and match these additional digital enhanced reality theme to that, you will be a lot more productive. Please do that. Okay, this is again a little contrarian slide. I believe, I think the people who have been in the industry for a long time like me should really try to caution you a little bit that what are the challenges in AI? A lot of people, they don't talk about it. Being teachers, we need to understand holistically what it is. Building trust. AI is higher technology, less on human side. I believe you have to bring it down to earth. A good teacher or similar to a good doctor commands a premium. And I believe teachers are good agents really to put AI in the right place to build a trust that people can take it forward. AI, this thing, human interface to AI. Again, teachers are the best agents for that one. Investment. at this point of time, investment, it is a little capital intensive, but I believe that this thing, education sector doesn't have doesn't have too much of money, but I think our governments are completely aware of it. They are funding it reasonably, and I believe we should try to exercise our judgment and draw upon wherever funding is available to make it happen. Software malfunction is a real risk, and I think one should not. I mean, I think a model can be good to the extent of 30%, 40%, 60%, maybe 80%. But I think you should not really put all your eggs into one basket. And I think software malfunctions are real, and I believe one should be little aware of it. Creativity and heuristics, I have already said that teachers, while we are learning AI and teaching AI, you should not neglect the heuristics part of it, the human elements to it. And I believe your primary job is to help students or the class to use their own human intelligence for normal things. And I believe students are coming to class today to learn that part. High expectations and regulations. This is a little legalistic. Let's not get into that one. One should be very reasonable about what you expect out of AI. Don't don't put all your eggs into one basket. It is only a supplement as on today, which probably in future it may be maybe in the next few years it will become a lot more dependable. But today I think what we have in the education sector is probably has to live in a hybrid environment. This thing, technology plus human beings, they have to work together to make educational outcomes better. Again, I think many of you would be able to recognize this gentleman. I think I have taken a wise word from his statement. Over time, we'll have to figure out what is responsible AI. And I think we should not really lose our oversight of, about the human side of things and use it cautiously. These are some of the. I believe. I mean, I have pretty much covered what I wanted to say, and sorry, I mean, because of I mean, I had to really leave out a lot of details because time was just too short. But in summary, I'll just say it again. AI is being adopted at a great pace everywhere and will continue to flourish. No doubt about it. As I said, you have got two dimensions of it. Horizontal part of AI and ML, that is what you are learning a lot in this course. But you also need to build your capabilities in verticals like education sector to really get real benefits out of it. In the context of recent pandemics, where many more human activities like teaching, research, transactions are becoming predominantly online, AI can be used as a double check for efficiency, objectivity, and transparency. We need to create suitable manpower at all levels to address the needs of for a meaningful AI deployment. Very important, meaningful AI deployment. That is where the teachers, they have a great role to play in trying to pick out the things which are right and probably filter out the things which are not right. As a technology teachers, we should take it as a mission and oversee the proper usage of AI and its associated technologies, particularly in the field of education and training. I believe I have come to the I've given a very quick summary of all my slides, but I think those of you who are interested can spend a little more time on the slides. There is a lot more content in this, which will give you, which will have some food for your thought. Thank you again. I think it is a pleasure to talk to you. Thanks to Dr. Sukla and his organization. They have been good in disseminating a lot of this useful information. I wish all of you get a quick expertise on AI and ML and the associated technologies and use it in your domain successfully. Thank you.
Thank you so much, Dr. Mishra. It has been a wonderful presentation, and it has been eye-opener for many of us to hear some of the even the contrary views also. So it has been really learning, and you have put everything, all the AI and machine tools together in context with the education. So thanks a lot for joining and giving us such a wonderful presentation. On behalf of all my the audience and all my faculties, and also on behalf of AICT, the AICT Academy of Training and Learning, that is Atal Academy. So we thank you for being here, and then in a short time you have given a lot of food for thought. Thanks a lot, Dr. Mishra.
Thank you.
We love to, like, if you are able to join in physical mode, we love to invite you. But yes, the again.
Well, I stay in Delhi at this moment. Not the best. Travel next time maybe. This time
Yes. Thanks a lot. Thanks everybody. Thank you so much. Good night. Good night. So we are leaving the this thing, and sorry for delaying your dinner
No,
for almost.
I mean, if there is some quick questions, I can take one or two if it is there, or else I mean they can send me an email also. That's not a problem.
Yes. If anybody is having any questions, can put forward. Otherwise, yeah, I will be sharing the PPTs where the mails, the email and contact address of Dr. P.K. Mishra is there.
I do not probably pick up unknown numbers on my phone, so I may not be able to talk to on phone. But please do send me an email. Every email, if I get an email, I will definitely reply to that.
Thanks a lot. Thank you so much. Thanks a lot. Yeah. Okay, so there being no questions, will now take a leave, sir. Will yeah. So namaste, sir. Namaste. Thanks a lot. Thank you, everyone. Good night.